You can hear me? Yes. Okay, so first of all, I would like to thank the organizer for having me today, for having brought maybe all of us from far away in the world. It's very nice of you to have organized this extra event on top of the Congress, and I really appreciate, and I think that everybody do so. So this is a joint work with Semenoff and Strausz, which is called the theory of contract with limited enforcement. So contract theory is very nice, because contract theory mechanism design is very nice. I know that I'm not going to use it. It's very nice because it offers a complete characterization of the set of incentive feasible action in context where you are informationally constrained. We have a very beautiful tool for doing that. We have the revelation principle, and once you have the revelation principle, once you have this full characterization, then you can proceed to normative analysis, find an optimal contract, an optimal institution, and relate that to the information that the different players have. Okay? What this theory is a little bit mute about the enforcement problem. I'm not okay, I know. You are going to say that I'm wrong because there are plenty of instances where the enforcement is an issue. Okay, we are going to discuss that in a while, and you will see in which sense what we are doing is slightly different. But I'm not the first to make that kind of remark, and this guy, Scott Maston, which is a guy working in transaction cost economics in the line of Williamson and others doing some empirical work, has also recognized that the theory of contract design and the theory of enforcement are something which are a little bit disconnected. This is also the view taken by law scholars. Law scholars, they are very much interested in enforcement and implementation of contract, and not as much in what we are interested in, which are the difference between the first best and the second best that you get with informational constraint. Okay? So once we talk about friction and do contract theory, we are talking about this informational friction, we are not talking about friction coming from the legal environment, let's say. Our theories make no link between this legal environment and the distortion, the difference between the first best and the second best distortion. So my goal here in this talk is to make such a relationship. We know that in mechanism design, contract theory, the difference between the first best and the second best comes from replacing cost by virtual cost. I want this virtual cost to capture also some parameter of the legal environment. Okay? So this is the goal. Okay. So, again, I don't want to be too extreme. There are plenty of contribution in contract theory that implicitly refer to the legal system. When we do moral hazard, we say this effort variable is not observable, not verifiable. When we do incomplete contract, we know that some variables are not verifiable and cannot be used in the contract. But this is a kind of all or nothing approach, and what we are going to do is a little bit different. So the topic of the paper is, like the title indicates, to develop a theory of contract under imperfect enforcement. And we are going to do so in a bare-bone model of trading relationship between a buyer and a seller. This relationship, we all know how to solve it, we all know what are the inefficiency, and I want the legal system to enter a little bit there to impact on those inefficiencies. I'm going to study the design of long-term relationship subject to enforcement constraint in this environment. I'm going to link the contracting friction to this imperfection in enforcement, and I've talked quite a bit since the beginning of this presentation about the legal system, the system of punishment that you can use if contracts are not enforced, but there are also private side to the enforcement. One being that if one agent do not obey to what is requested by the contract, then the other may just forgone any future trade with this deviating agent. Okay. And I'm going to study what sort of consequence we may have for contract and organizational design on examples. So I'm going to start with the literature review. My literature review, I just want to have only one slide, so I'm not going to quote all the contributions because there are tons of them. Just to give you an idea of where we are going to be. What do we know about dynamic contract theory? Well, we know quite a lot about dynamic contract theory with full commitment. With full commitment, let me insist that it's infinitely costly to draft new agreements as time goes on. There is only one agreement that is set up at date 0, and we go for that forever. In any given period of this relationship, the transaction can be perfectly enforced if the price to trade a good and the quantity of that good are determined ex ante. These are the price and quantity that will be traded under the relevant history. Renegotiation, well, it is costless to write a new contract. When day 2 comes, if the party find it optimal to write a new contract, they write a new contract. The transaction, again, in any given period, whether the price and the quantity which are agreed upon, once the contract has been signed, this is the price and quantity that will be traded. Short-term contract, it's infinitely costly to write a long-term contract. We can only write contract that covers the current period, and within this period, the transaction can be enforced. The price and the quantity that are supposed to be used are going to be used. In this environment, there are, especially in the case of short-term contracts, there are plenty of technical difficulties. We all know what they are. There is imperfect revelation of information. The ratchet effect, a good guy don't want to be revealed as a good guy earlier on because he will be expropriated ex post. To avoid that, we all know that the principle we like to do in the first period to make very attractive the allocation of the good guy. You want to pay a lot a good guy. But if you do so, then you go into this story of take the money and run strategy, where a bad guy can be attracted by this high reward that you make earlier on to a good guy, and then leave the relationship because we are under short-term contract. So I'm not going to sing this song, take the money and run, but I could. If I was in good shape, I would do. Relational contract, we go even further away from that. It's infinitely costly to write any contract, okay, and to secure any transaction. And then, instead of being contract theory or mechanism design, is just game theory. We want to see how the relationship can be managed when guys cannot really write a contract and have to substand the behavior, substand their trade by the repetition of the relationship. So the literature there is huge again and very active. And here I've quoted a little bit more of stuff because sometimes people believe that what we are doing is relational contracting. So I have tend to add a little bit more of references. Maybe the one I want to insist on here is the one on stationarity. Levin has a very important paper on relational contracts, where you look at the relationship between a principal and an agent, or two agents, I don't know what to say, but there is no contract. We are risk neutral, and where and under some circumstances it shows that the environment can be when the environment can be stationary, the contract itself is stationary. Okay, you can implement an allocation with a stationary contract. This is very much due to risk neutrality and a little bit of risk aversion, like what Pedro did in his thesis, would invalidate this result. I will come back to his Levin result and how it compares to ours later. Within the framework of relational contract, there is a few papers who look at an environment with persistent type. A persistent type environment is one where the type is wrong, remains the same all the time. So the environment is not really stationary, because there is something that has been revealed in the earlier period that can be used in the second period. This literature is mixing a bit something which is related to the ratchet effect from the more general literature on short-term contracts, but we will see that we can do also something which is related to those effects in our framework. Okay, anyway, so where are we? I'm going to consider a relationship with full commitment, where the party can write down a contract that covers the whole length of a relationship. They commit to this contract. Transaction in any given period can be enforced, but at a cost. I will come back next slide on that. So if anyone does not deliver what is supposed to deliver, there will be some liquidity damage that have been designed ex ante in the contract, that are written in the contract, and the courts enforce those damage. This is the legal doctrine. Okay. And this is what happens in real world. I will come back next slide. This is a world with persistent type. So before contracting, the buyer learns his type. And this is a world where nevertheless, even if we have full commitment and persistent type, we will have something which is a take the money and run strategy, which looks like what we have with short-term contracts in the previous literature, okay? But which is much easier to handle and which gives rise to interesting and nice dynamics. Example, does this situation arise somewhere? Yes, construction contract. So construction contract, beforehand they write books to describe exactly what will be the contract and exactly what will be the different stage of the contract over time. What will be the stage of delivery by the seller, by the constructor, and what will be the monetary transfer by the buyer at each point in time. Okay? If anyone does not deliver, if there is missing deliveries at any stage, missing misspecification, missing of dates of completion, then there are liquidity damage that have to be paid by the party who is faulty. Okay? This is an environment where you have bilateral opportunism in the sense that the buyer may not deliver the payment in due at due date, and the constructor may not deliver the stage he's supposed to deliver or the right specification in due time. Franchising contract have also a similar feature, and some financial contract with exaggerate financing for venture capital and exercise of exit right. So the model, the main ingredient, this is a very simple model. So on Saturday we were in kindergarten, 1 hour before we were in high school. So here I don't know where I'm very low. So the preferences are quasi linear. There is a buyer. The buyer here who cares about the surplus he gets from consuming Q2 units of good at day 2. He pays for that. The seller pockets the money as a cost, and he has private information on his marginal cost. The cost is run once for all. This is a very simple model. There are only two types, low and high, with the probability which are common knowledge. The standard trading model. The buyer has all bargaining power. This is an uninformed party, maybe, once there is private information later on. There is commitment to the contract, to a long-term contract that specifies price and quantity over time. And there is a possibility of penalty for breach at any point in time for both agents if anyone deviates and does not obey to what is requested by the contract. So let me move on. I will come back to the detail of the technology in one slide or two. With full commitment and a costless enforcement, we all know what is the solution. First, consider the case where we have only one period. The solution is the usual Baron-Meyerson solution that Roland has described before, except that here my model is a bit different. Instead of having 0,1 unit to produce, here I have a continuous level of output. We know that we have to give a rent to the low-cost seller. We don't give any rent to the high-cost seller. These are the payments. I'm stressing the payment here because later on with the enforcement constraint I'm going to talk quite a bit about the payment. So let me stress the payment. So these are the payment of a low-cost guy. He covers his costs and it rewards the guy for his informational rent. Fine. This is a payment of a high-cost guy, just cover his costs, usual stuff. The rent of the good guy is proportional to the output of the bad guy. This is costly to give rent, so you need to distort a bit more the output of the bad guy to reduce the cost of incentive constraint. The virtual cost here capture this effect. It is above the true cost in case you face a high-cost agent, a high-cost seller. So what I want to do at the end of, or not at the end, maybe in the middle of this talk, is to modify this virtual cost, to have it including something related to the legal system. Okay? So I want to put Meyerson into an enforcement problem. This is dynamic. When you consider the dynamic version of this game, following Pavan and Besanko, we know that the optimal contract is simply has an output which is the infinite replica of the static contract. The reason is very simple. In the infinitely repeated version of the game, the overall rent is simply the sum of the rent that you get in each period, discounted of course. You need to give the same incentive pressure for inducing information revelation in each period, so you make the same distortion. Not a big deal. Of course, you may have a little bit of freedom in specifying the payment to implement this outcome. But one possibility is simply to have a stationary contract, okay, offering the same payment over time. You could commit to something else. You can commit. You could commit to a path of payments, but the output will have to be the same. Okay. Now, slight modification with respect to this environment. The contract can be breached by either side, the buyer or the seller, at any point in time. And to talk about breach of contract, we need to look carefully at what is the transaction technology. So I want to talk about a contract, a transaction between a buyer and a seller, where maybe the seller does not deliver the quantity or the quality that we want, or maybe the buyer does not pay what it is supposed to pay. To do that, I'm going to decompose this trading period between two stages. In the first stage, there is a pre-delivery price, maybe, which is paid by the buyer and which is pocketed by the seller. The seller can't pocket this money. Once he has pocketed that, maybe he doesn't want to deliver. Okay? In which case, the transaction has no value for the buyer. Okay? You can think about maybe the quantity is still the same, but the quality is not the right, and then we have a transaction which has no longer any value for the buyer. Once the right quantity or the right quality has been received by the buyer, still within the same contracting period, the buyer can just not pay the post-delivery price. Okay? So there are two instances of opportunism in those relationships, by the buyer and by the seller, not taking place at different date, sub-date of this single trading period that I'm considering. Okay? And what I want to do is to design a contract which ensures obedience on both sides of the relationship at this stage. Okay? I want the buyer to pay when he has to pay, and I want the seller to produce what he has to produce. And we will need to structure the overall payment within the period, and maybe dynamically so also, in order to solve this bilateral opportunism. Oops. So to do that, I can use two things. I can use first the public side of enforcement. I can have penalty for breaches, and those penalties, they will be enforced. The court is there somewhere The court has determined what are the penalties. This K and this L, which are paid respectively by the buyer or the seller, are determined ex ante. These are not something that we are going to optimize over. These are the level of liquidated damage, and the court enforces that. This is the commitment ability of the court. And we have also we can rely also on the private side of enforcement. One of the motives for continuing to trade, to behaving, is simply because there will be a further stage of trade, and each party wants to get the gains from this further stage. And there are law scholars like this guy, who has written an important book on those issues. An important textbook in law and economics, which recognize that the two have to be analyzed all together. If you look at the relational contracting literature, what they do only is to look at the private enforcement side. Okay? But even if we have both sides, public and private, maybe we are not able to secure the transaction. Until when do I have? 20 minutes. Okay. So there will be friction due to imperfect enforcement. A little bit of notation. So this is your average output over time, starting from date to on. This is the same thing for the payoff of the seller. This is the same thing for the payoff of the buyer. This is something which is a kind of average output, but from date 0 to date 2, not included date 2. This is something which is a payoff of the seller from 0 to date 2, including the possibility that at date 2 the guy pocket the money and then pays the damage. So this is not really an equilibrium payoff. This is something that we want to avoid. We want to avoid that the agent gets that payoff. That payoff corresponds to the case where he has misbehaved. He pockets the pre-delivery price, but we pay the remedy. But nevertheless, this is an important ingredient to write down the dynamic incentive constraint. So let me define first what I call the enforceable star allocation. Star, why? Because as a first pass, I'm going to consider the case of complete information. Okay? Why? Because first it is kind of pedagogical, I don't know, but it is useful to consider that case to see what asymmetric information and private information on the seller side will introduce in this framework. So the usual, the transaction at day 2 can be secure, will be enforced when both the buyer and the seller behave, trade what they are supposed to trade. This is the incentive constraint of the buyer. You compare the gain from the continuation with the gain from deviating, and not paying the post-delivery price, but having to incur the damage, the liquidated damage. For the agent, you can write also an incentive constraint like that. But I'm going to write this constraint in a slightly different way. I'm going to write this constraint in terms of what has happened from date 0 to date 2, and then adding the continuation. So this means that behaving all the time gives an equilibrium payoff, which is this U0 theta from date 0 to the end of the game. But the guy with type theta could choose to behave until date 2 and then deviate, okay? Which give him this payoff. Okay? So this is for an agent under complete information, this is the payoff of the deviation. So the next step is to aggregate this. We are not the first to do that kind of aggregation. Levin, for instance, does the same thing in his environment with relational contract. You aggregate the principal and the agent incentive constraint into a single constraint. Since you do this aggregation, of course, all that matters is the sum of the remedies in a given period. M equal to L plus K. So I'm not going to talk much about L and K in the rest. And the nature of this aggregated constraint is simply that the future surplus of the relationship has to be greater than the sum of the benefits of deviating. Okay? So you have to sum up the benefits from deviating on both sides of the relationship. Okay? Okay, this is a very general condition that will hold under complete information and later on under asymmetric information. Except that I'm going to modify those benefits, of course, because of Sorry? Yes, it's true. Yes, there is a point on the side on that. I come to that in a minute. So this is my enforceable profile. My enforceable surplus from date tau on. The continuation is enforceable if this quantity is positive. Okay? It has to be positive for all theta. Theta is complete information, and for all tau, for all date. Okay? And the mechanism is enforceable. So if you look at this thing, you see two things. You think first that in the surplus of the enforceable surplus, what we get is a future surplus of the relationship, but the cost is the current cost of production. And this current cost of production corresponds to the benefits for the seller of not delivering. So this is something which makes it costly to enforce the contract. So a given output at date tau, if you want, is costly from the point of view of date tau, because the higher this cost, the harder it is to enforce the contract at that date, because a seller would like to deviate and not to deliver, not to pay that cost, fine. But this output at date tau, he enters also into previous enforcement constraint as a surplus, as something that contributes to the future surplus of the relationship. Okay. Anyway, this constraint, this enforcement constraint, do not depend directly on time. They just depend on time and directly through the output that you choose from date to on. So these are a system of constraints which are autonomous in a sense. So here I have proceeded by implication, just aggregating individual incentive constraint into an aggregate constraint. One may ask whether it is possible to find a contract that implements an enforceable allocation, find the payment that implements the given profile of output. Yes, it's possible, and it's relatively easy to do so. Since I don't have too much time, I'm going to pass on that. So, since the constraints do not depend on time, maybe it makes sense for the moment to look at what a stationary contract will look like. Okay? So for a stationary contract, all the Q's are the same, fine. The surplus, the enforceable surplus takes this very nice expression. So here we have the M that comes from the legal system. And you have to maximize surplus. The principal payer, but since we are under asymmetric information, he will reap all the rent from the agent. So the maximum surplus subject to this feasibility condition. This is very easy. Either the feasibility condition is satisfied by the first best allocation, and then this is not a relevant constraint, this is not very interesting, or it is not satisfied, or this constraint is not satisfied by the first best, and then you have a constraint optimal. Okay? You have to reduce the output below the first best, and reducing the output, reduce the payment, facilitate enforcement. It's easier if you have reduced the output, it's easier to enforce on the seller side because it is less costly to produce, and it is easier to enforce on the buyer side because it's less costly to pay, and then he has less incentive to renege on his payment. Okay. Fine, but of course we are not sure that it is the solution. I'm just taking a stationary contract. So what I'm going to do to show, I'm not going to do it here, but what we do to prove that the solution is stationary, we do brute force. We write down the Lagrangian with an infinite number of forward-looking constraints, this enforcement constraint. We do macro, we do Rusticini. We look at the multiplier, we check that they satisfy a condition in Rusticini, and we check that for a stationary allocation we can find the multiplier of those constraints. Okay, and in that fact, doing this procedure, the optimal contract is stationary. The question is, could it be implemented with relational contract as in Levin? The answer is no, because of the M, because of the fact that we have the legal system. If you don't have the legal system, you will do something pretty well. You will do something which is implementing the Q that solve this equation equal to 0, but with M equal to 0, but it's less attractive than our solution. Okay, you could say, well, but we could have over-punishment even in a relational contracting, maybe some kind of hidden reputation cost of ceasing the relationship. Not liquidated damage, but something else. And maybe this something else could replicate this M. I completely agree with that. But if you look at the proof in Levin, he does two things at the same time. He does one thing, which is to prove stationarity given existence. Of course, we need to prove existence at some stage. Our approach proves simultaneously existence and stationarity. Another advantage of our approach is that you cannot guess the solution in an environment which will not be stationary. For instance, if the surplus are not the same in each period, you will have to change the approach. And this is precisely what will happen later under asymmetric information. So the brute force approach has some benefits, but it is unable to compute an optimal contract in other environment. Take the money and run now. No, you don't know. You don't know the Steve Miller Band? Okay. I'm the only one to know the Steve Miller Band? You know. You don't know? Nobody knows? Okay. Okay. So all those guys who have spent their life in the US, you don't know the Steve Miller Band? Steve Miller Band, you don't know? Huh? Yeah. You know? Ah, okay. Okay. So sometimes I should change. Huh? Yeah, you know. Ah, of course. Huh? Well, we're not so much in France, but in California, you should know. You should know. Okay. So take the money. So let us think now about this game under asymmetric information when there is private information. So I told you that we need to under asymmetric information. Baron Besenko told you that you need to give some extra payment to the agent to induce him to reveal the information. In a world where you have limited enforcement, giving this extra reward to the good guy becomes now attractive for the bad guy, where the bad guy maybe wants to take this high reward from the good guy for a while, and then breach relationship and leave. So the fact that we have limited enforcement plus asymmetric information let appear a strategy which is very much like the one that we have in the model of short-term contract. Okay? So we are going to study this strategy. So this new strategy. Now let us think about the role of time. If you're a bad guy, do you want to mimic a good guy forever and then breach in very far future? Well, if you do that, the longer the period where you mimic the good guy, and maybe at the limit, you are just, if you do that, you are violating incentive compatibility constraint. So, this incentive, those take the money and run strategy, they matter in the short run. A bad guy may be attracted, may be tempted to behave as a good guy for a while, but he's not going to be attracted forever. Okay, so time is going to play a role in this story. The enforcement constraints are going to depend on time, and there will be a dynamics of the optimal contract. Time? Okay, so this is a strategy. The agent is going to behave when telling the truth up front and not breaching the contract forever is the best strategy. So what he could do is to lie and reach at that point in time. So you look like this constraint 7 looks very much like a normal incentive constraint, but there are many much more than that, because you have over deviation by behaving for tau period and then deviating. Okay? In the limit of tau going to infinity, both incentive constraint gives you the usual incentive compatibility constraint. But there are more. Once you play with that, you can aggregate the principal dynamic incentive constraint with the agent dynamic incentive constraint written like on the previous slide. And you get a formula that gives you the surplus, the enforcement surplus has to be greater now than what it was under complete information. There are all those extra terms that comes along. And those extra terms in general will be positive. Okay? And there is time that enters into the picture, because the take the money and run strategy is less attractive in the future than today. Asymmetric information hardens enforcement, but do so in different intensity over time. Okay, so a reference here will be again to solve for the optimal stationary contract under asymmetric information. If things are stationary. So this is interesting because starting from that, one can measure if there is a valuable deviation towards the non-stationary contract. So if things are stationary, those enforcement constraints that I've written, the hardest one are today. So today, you need to give a surplus, you have this large payment that you give to the good guys so that you reveal this information. So there is this large payment comes with this extra rent here, and so the surplus, this enforcement surplus with this type has to be greater than this rent that you give on top. Okay, and you see that now the enforcement constraint depend on the output of the good guy and the output of the bad guy. So once these constraints are binding, both output have to be distorted. So this is what happens. There is a multiplier capital lambda of this constraint, and both there is a distortion of the output for the bad guy, because it reduces the payment that you give to the good guy, and so it facilitates enforcement when a good guy, when the state theta lower bar realizes. And on top, you want to reduce directly the output of the good guy, exactly for the same reason as under complete information. So there are two kinds of distortion here. Keep in mind that. Okay, so this I can switch. Let us play with this enforcement constraint and let us look at what happens when tau vary, when we are at different date. In the very long run, so I've rewritten this constraint, so I need to explain one thing. I have rewritten this constraint here, introducing this forward output and the backward output. The backward output, you see there is a minus delta Q lower bar of theta for the first period. This is exactly what is the extra cost for a bad guy when he mimics a good guy for tau period. He has to produce the quantity of the good guy, but at a higher marginal cost by delta theta. So this is costly to do that. There may be benefits later to take those transfers, but this is costly to mimic. And so this comes with a minus in the enforcement constraint. Otherwise, remember that we still have to give this large payment to the good guy in order that he reveals the truth. So this large payment is everywhere. And this large payment means that we have to give him this Q0 of theta per bar. When tau gets large, this term converges towards the output of the good guy. By incentive compatibility constraint, it is greater than the output of the bad guy. So this means that this term is strictly negative. So on the right-hand side, you get 0. So the enforcement constraint, in the long run, looks like under complete information. In the short run, instead, this term is 0, and this term is 1, and you get the same enforcement constraint than with a stationary contract. And so what we are going to do with the dynamic is to move from this towards something which is like that. We do so. First, we can prove that the stationary contract is not optimal. What you do is to exhibit a deviation where you are non-stationary, And one thing that you can do is simply to reduce the output at date 0 below the stationary level. If you reduce the output at date 0, then you reduce the payment. You don't touch the rest. You reduce the payment, and this facilitates enforcement. Okay. Just because you have reduced also the cost of the seller, it makes it less attractive for him to misbehave. Okay, so of course there are circumstances when M is large. Take the case where M is very large. There are circumstances where the enforcement surplus is strictly positive and we don't care. What we care about is a situation where this constraint will be binding along the way. And the dynamic, in fact, goes through two different phases. There is one phase which is a growing phase where the enforcement constraints are less and less binding, the Lagrange multiplier are diminished for those constraints, and you have increasing volume and prices. And there is a mature phase where the enforcement constraint is no longer binding, it is slack. There is efficient trade with a good guy, stationary price, stationary payment, but this allocation in the long run keep track of all what has happened in the previous period. So I don't have time, so this is the description of the early phase. This is the description of the long run phase, and I'm going to insist on this. So this is the virtual cost story. The virtual cost story, which is modified now by a something that I call lambda infinity, which is the sum of the multiplier discounted in some way. The sum of the multiplier of all the enforcement constraints until someday tau star where these enforcement constraints are no longer binding. Okay. So you have, but the distortion in the long run keep tracks of all those earlier period, because remember that in any case you need to give to the good guy a rent which is proportional to the output, so to the final output. So you have to keep track of all the distortion, all the earlier distortion. This formula is nice because inside here you have capital M. You have the quality of the legal system, if you want. Quality of the legal system goes through the distortion, the long run distortion. The early phase is very much like what you find with the kind of output distortion that you find in this early phase is very much like what we find with a stationary contract. There are distortion of both the good guy and the bad guy along the way, but less and less distortion of the good guy. At some point, you stop distorting the allocation of the good guy, but you keep the distortion of the bad guy. And this distortion is rather inefficient. What do I want to say? Okay. Okay, so you understand that since the problem is to take the money and run strategy in the very few period of the relationship, because in the long run it don't matter, a bad guy is not going to mimic a good guy, you need to do extra distortion only in the early phase. In the long run, you no longer care as much, so there will be efficient trade with a good guy in the long run. So you could compare that with what other model of dynamic contract would tell you. So in any case, here we are able to link the efficiencies of the public and the private side of enforcement with the distortion, long run distortion. This is the only thing that I want to insist upon. Maybe the implementation. So if the problem is for the bad guy to mimic a good guy for a while, there is a simple way to implement the allocation, the corresponding allocation, in a way that prevents that, which is to bind the reverse incentive compatibility constraint for a while, per period. So then a bad seller is not going to gain anything by mimicking a good seller for the earlier period. Okay. Then what you do, if you are constrained with your payment in the earlier period that way, you still need to give the rent at the end of the day to the good guy. So you need to give higher payment in the late period of the relationship. In the mature phase of the relationship, you give the 2 star, you beyond 2 star, you give the payment which are higher and increasing. You can evaluate the length of the growing phase. I don't have time. You can play with that. Just one very simple play. Okay, we can compare what happens. Suppose that the principal and the agent here are within the same field. And suppose, following Riordan, that once you are vertically integrated, you know the information. So what this model predicts is that if you have an enforcement problem, and that you are in a situation close to vertical integration, there will be a path of the relationship which is very stable. He said if you are in a market relationship where there is asymmetric information between the buyer and the seller, the relationship is going to grow at the beginning before getting to a mature phase. And there will be take the money and run strategy for the in the earlier period. And this again in the sector of construction contract, it happens quite a bit. Very important to have two-sided opportunism in this environment. If you have only one-sided opportunism, well, you can solve it easily. You can use the flexibility that Baron and Besanko gives you to determine the overall profile of transfer to solve the enforcement constraint on one side. The only problem comes once you have this moral hazard team. Both guys may be opportunistic.
So thank you, Yildiz and Umberto, for organizing this great conference. It is a great paper. It was a pleasure to read. I don't know if I have something useful to say. Let me try. So the paper has many nice features. One of them is that the setup is very basic. It's very simple. Indeed, I can summarize in one slide. There is a buyer who is willing to make some side payments for the seller who produce good at a marginal cost theta. Theta can be high or low with some given probability. Once it is drawn at the beginning of the period, it stays constant for the whole contract, for the whole time of the contract, and at time zero, buyer offers a take it or leave it long-term contract to the seller. Another nice feature of the paper is that you can link this big setup to two useful benchmarks that I'm going to talk about later to make one point. So under complete formation and full commitment, you have efficiency and the seller makes no profits. The buyer extracts all the rents. Under asymmetric information and full commitment, you have an infinite replication of the static optimal contract, and you know the statical optimal contract distort the inefficient type so he can provide incentives to the efficient type. As you know, high cost seller will make no profits and the low cost seller makes some profits. So here is the contribution of the paper, as I see. So I think the way the authors model cost enforcement was very ingeniously. They divide each period into two sub-periods, and in the first sub-period, the buyer must make some transfer before the quantity of the good is delivered. So the seller may not deliver the good, and if it happens, a penalty L must apply. In the second sub-period, the buyer must pay the remaining of the transfers after the quantity is delivered. If the buyer doesn't pay the transfers, if he repudiates the contract, a penalty K applies. So how the paper interpret this setup? They they rely on the penalty doctrine to justify the penalties L and K. In principle, if the penalties were endogenous, one can set them to infinity and recover the benchmark cases. That one would be a problem, but in practice, courts refuse to enforce extreme penalties. And at this point of the paper is very exhaustive. They try to work out every case step by step. So I'm not going to comment much on the results. I'm going to comment more on the motivation of the paper. So for me, the paper carries a mix of normative and positive analysis. On the normative side, we want to understand the desired properties of a contract. On the positive side, there are some legal restrictions that some legal restrictions on the trading process. Understand how these legal institutions change the properties of optimal contracts seems, at least to me, could be a very promising avenue of research. And why I'm saying that? Because the courts of law rely on many doctrines that may interfere with the trading process. So let me say one of them that might suit very well the basic setup of the paper. I chose a doctrine that I don't know how to pronounce, the unconscionability doctrine. So what the unconscionability doctrine says? So here I learned from Wikipedia that unconscionability is a doctrine in contract law that describes terms that are so extremely unjust or overwhelming one-sided in favor of the party who has the superior bargaining power that they are contrary to good conscience. Typically, an unconscionable contract is held to be enforceable because no reasonable or informed person would otherwise agree to it. So this unconscionability doctrine was applied everywhere in a lot of countries, the world, United States, England, Australia, Brazil, among many other countries. So if the name of the game is to study how the design of the contracts changes due to legal restrictions, this unconscionability doctrine seems to fit very well the base setup of the paper. First, there is a huge unicality of bargaining power. The buyer has all the bargaining power by take it or leave it offered. At least in some cases, it seems to have very unjust outcomes. Under complete information, the seller's rent is fully extracted, and under asymmetric information, the high-cost seller's rent is fully extracted. So it seems to me that many courts in practice will hold the setup in the paper to be unenforceable. So my next question is how, instead of interpret the setup of the paper in terms of the penalty doctrine, I'm going to reinterpret the basic setup of the paper in terms on the unconscionability doctrine. Clearly, the weak part of this setup is the seller, and the strong part is the buyer. So one interpretation of this unconscionability doctrine is that the weak part faces substantial smaller penalties than the strong part in case of dishonoring the contract. That is the L, which the penalty inside on misbehavior of the seller should be substantially smaller than K, the penalty that inside that applies in case of misbehavior of the buyer. I think this is important because this is in line with implicit assumption in the paper that L has to be small enough so that post-delivery transfers are positive. Otherwise, the post-delivery transfers could be negative, and then the seller must reimburse the buyer, which introduces another enforcement constraint in the problem that is not dealt with. So, in one sense, the unconscionability doctrine may help substantiate an important assumption in the paper. But another interpretation of this unconscionability doctrine is that, look, the court will only enforce the contract whenever the weak part assesses the court. If the strong part, so you ended up in a case of one committed on side. Only the weak part can repudiate the contract. So this is another interpretation of this doctrine. If that's the case, you can say the penalty very high for the buyer, and as a result, as in the paper, limit enforcement is innocuous. So I think that the message I want to say here is that depending on how we interpret this unquestionability doctrine through the lens of the model, you have two different conclusions. One, that all the results in the paper are reinforced and limit enforcement is relevant to interfere with the trading process, and another interpretation will give us will say us that limit enforcement is innocuous. It doesn't interfere with the trading process. Which one is right? I don't know, but somehow we have to struggle with these two possibilities. So that's my comment.
We have some time for one question, maybe Lucas. It seems that for m is equal to 0, you end up like at 11, right? And okay, and then and then no, I understand, but let's consider the case that perhaps some of us are more familiar with. In that case, it seems to be that what we're doing is inserting private information to that game, inserting private information in that game, and the issue that the difficulty that you have is that Sorry? No, I understand, but yes, you can write, but yes, but it's perhaps I didn't understand something. But
I didn't get the beginning of the.
It seems that if you have but you have commitment, but you have a cost of breaching.
Yes.
I mean, if this cost is zero, is as if there's no commitment, right?
Under complete information, but not.
Okay. So let's think. So my question would be: no commitment, the usual leaven with incomplete information.
Yeah.
Seems to be related, and there it seems to be that the hit and run strategy would also kick in.
Yes.
And then there it seems to me that for any equilibrium, so what you want to do is to minimize the incentive of the high cost to imitate low cost and renege on the first periods. And it seems that for any then one thing that you could do is to take an equilibrium there and construct another equilibrium in which you would do which would essentially do the following: make the low cost pay everything up front, and then then become the residual claimant in every period. Because by doing that, you would minimize the incentives of the high cost imitated in reneging the contract. So because what we want to do essentially is just
So it's yes, maybe yes. So here, when m equal to 0, so the framework that you have in mind is a framework where there is no commitment at all. Yeah, Levin. Here we have commitment. So we have commitment. We still have a take the money and run strategy. So I don't understand what what your question is. Is it, do we do better than the equilibrium that you suggest?
Look at a subset of contracts, a subset of equilibria. My intuition says that.
Okay. We don't care about the equilibria. We care about the optimal contract, full commitment with an enforcement constraint. In the spot contract, in Levin.
Just make the low cost pay to the principal in the first period and make it residual payment, because that would minimize the incentive of the high cost to hit and run in the first period.
Yes, but so I still don't understand the question. I apologize. This is what you do in Levin. Yes. Yes. Well, there is a paper on that by Malcolmson. I don't know if you know it. Okay, so Malcolmson had done that. So the point, the difference between, maybe we should be more explicit in the paper. In the next version, maybe we'll be. The difference between Malcolmson and us is precisely that we have the commitment ability. So once you don't have the commitment ability, you mix two things. You mix imperfect revelation plus the take the money and run strategy. Our framework allows us to say an enforcement problem, and relational contracting is an extreme enforcement problem. An enforcement problem is already enough to get take the money and run strategy. So this is the message, I feel. But okay, here the take the money and run strategy, even when they are binding and give rise to this set of enforcement constraint binding, still all information is revealed upfront, full commitment. So maybe we should be more explicit about in comparing our dynamics with Malcolmson dynamics. This is interesting, but let me put the emphasis the other way. There is this rational contracting literature is very active, very interesting, but in the real world, when you the example that you get out of this literature are always the Japanese firm, the suppliers, this one example that comes in all those papers of relational contracting between productive firms. This framework doesn't allow you to cover many instances where enforcement is an issue and long-term contracts are written and possible. Construction contracts, there are huge books written upfront when the buyer and the seller meet to describe what will happen for the rest of the life. So my claim is that the emphasis on relational contracting is a bit excessive. There are plenty of situations that are not covered by relational contracting, that are relevant for enforcement, that are interesting also, because you can study the same kind of insight, take the money and run strategy, in an environment where you have full commitment, which is much more tractable. We all agree about that, because you don't have this imperfect revelation of information. So overall, the point should be, it's when you do relational contracting, you relax two things at the same time. You no longer have a long-term contract, and you can no longer enforce things. What we do here is that we relax only one thing with respect to the standard paradigm, full commitment, full costless enforceability. So the burden of the proof should be on the rational contracting literature. The burden of the proof to demonstrate that it is relevant should be on the paradigm which makes the most, which reflects the most assumption with respect to the reality. Okay. I think. We may disagree.
Yes. Thank you, Eduardo, also for the discussion. And I think we're done. I thank you very much for coming here, especially the speakers and discussants. I appreciate very much the effort to be here in Rio. It's not that hard, I know, but still to be here at this time and keep attention is very good for for us that's try to do research in theory. And I'd love to thank also Getúlio Vargas Foundation for providing us the capacity to do that. Thank you all. I hope to see you in the future in another conference like that.